We are the students of Vishweshwarya National Institute of Technology. Here is the video presentation of our project Safety Radar for Mining Areas. According to reports, there have been many casualties in mining areas due to excavator and truck. So we have come up with a probable solution of using radar as a detector system. This is a block diagram of our radar system. We have used a triangular wave of 25 Hz of peak-to-peak voltage 2 to 3.2 volt as a modulating wave. We have used an oscillator of 2.4 GHz frequency as a carrier wave. The signal that is generated from the oscillator is passed to the attenuator and then to the power amplifier to the splitter. From the splitter, the signal is divided into two parts, in which one part is transmitted in the surroundings and the other part is given to the mixer. The signal after reflection from the object will come to the receiver antenna and it will pass to the low noise amplifier. The low noise amplifier will suppress any noise in the signal. Then the signal is again fed to the mixer input. The output of the mixer is given to the comparator circuit, of which one of the reference value is being set by our lab experiments. The output of the comparator is given to the LED system. The LED will glow when the received signal from the receiver antenna will be more than the reference value. Now I am going to explain you the principle that we have used in our radar system. Suppose the transmitting wave that we are transmitting is shown by this blue color and the object is shown by the red cross mark. The wave that is reflected from the object is shown by this red color wave. The transmitting wave and the receiving wave are the two cosine functions of same frequency but with a phase difference, as you can see here. Now this is the position of my mixer. Now what my mixer does is it multiplies the two cosine functions. So the result of the output or the output of the mixer will be a cosine function whose argument will be the phase difference. So what we get from on the DSO will be a DC value proportional to the phase difference of this value. Now if my object is here, I get a DC value something like this. Now if my object is here, I get a DC value something like this. If my object is here, I get a DC value something like this due to the difference in the phase difference. Now if I add a velocity component to my object, it's moving from this position to this position, my DC value is going to change from this position to this position and to this position, something like this. You can see. So this is the principle of blocker shape that we have used in our radar system.
This is the actual circuit diagram of what we had seen on the blackboard. Like we had seen, the circuit starts with an oscillator. Here the oscillator generates a signal with 2.4 GHz frequency. Input to this is a modulating signal, which is a triangular signal with frequency 25 Hz and 2.5 volts peak to peak. Next, there is an attenuator and a power amplifier. The attenuator here suppresses any reflected waves from the power amplifier, whereas the amplifier amplifies the signal so that we have high transmitting power at the transmitter. This high power signal is then sent to a splitter. Basically, a splitter splits the input into two identical outputs. One of the splitted signal goes to the antenna. Here, this antenna is from Texas Instruments. This will be reflecting waves into the environment. Now, any waves which reflect back from an obstacle will be received by the receiver. Now, the received signal is sent to a low noise amplifier. The low noise amplifier removes all the high frequency noises and also increases the power of the received signal, since the received signals are usually very weak. This amplified signal is then fed to the mixer, whereas the mixer's other input is what was transmitted. So the mixer gives us a difference between the transmitted and the received signal, which here can be displayed on the digital storage oscilloscope and can also be used to create an alarm. Now here, all these ICs require a supply of 5 volts. Now we need this device to be handy as it is to be used in mining areas. So we have used a battery pack which provides 6 volts. So to bring down the voltage to 5 volts, we have used Texas Instruments IC 7805, which can be seen here. Now this steps down the voltage to 5 volts, which is given as the input to all the ICs.
Hello everybody, I am here to explain you the alarm system which we have built. We have used the IC TI-IC UA741 as a comparator, in which the inverting terminal is that of a reference voltage which we have chosen from the laboratory experiments. The second non-inverting terminal gets an output from the mixer. The comparator compares these two signals and gives an appropriate LED output. Hello everybody. I am here to give you a working demonstration of a radar here. As you have been told earlier, the received signal is given to a low noise amplifier which in turn gives the signal to the mixer, whose one input is that of the transmitting signal. The mixer output, as can be seen, is clearly given to a DSO. Now, as the DSO signifies, without any object before our radar, a fixed DC value between the range of these two bars exists. And as you can see, with the motion of my hand, a clear disturbance in the output signal will appear on the DSO. Here is a demonstration for that. I'll make that go again. A clear disturbance can be seen in the output of the DSO. The principle which we have used over here is that of Doppler shift. And this principle, the disturbance signal, is then used in our signal processing part in the generation of an alarm.
With you the lab demonstration of our radar system. As you can see, this is the output of our radar system that we are going to give to the alarm system. Now, whenever a moving object is moving in front of the radar, you can see that the LED is glowing. Now, as you can see, whenever the alarm system is going to, whenever the alarm system is going, whenever the movement, there is a movement in front of the radar. So, if there is a movement in front of the excavator, also the driver is going to learn about the movement by the alarm system. I'm going to explain the rotation mechanism of our radar system. This blue diagram will show the excavator, and this red diagram will show the arm of the excavator, which is nearly 5 to 8 meters. Now, as you know, the excavator arm rotates nearly in the angle of 150 degrees. Something like this. Now, as we have earlier shown in the video, my radar is going to detect any movement in the straight line. Now, if I am going to move my radar something like this in this region of area, such that I can get 4 rotations in 1 minute, then I can detect any movement in this area of surrounding. So, in this way we can detect any movement in front of the excavator and can give the alarm to the driver. In this way we have built the radar system.